point and purpose. So, bonjour everybody, and I hope you enjoyed your meals and didn't eat too much, because we're going to talk about slightly complex systems. Yeah, sorry. Okay, so first, small thing about me. So I'm managing the solutions polyconseil team with building carpooling service in Paris with electric cars, and in Lyon, in Bordeaux, London, Indianapolis next year. We've been open sourcing or managing a couple of libraries. Perhaps you've heard of Factory Boy, and for those less likely. So feel free to ping me for any questions, feature requests, prints, whatever. I'm Raphael Barrois on Twitter, Barrois on GitHub, and Tenor on IRC, because I don't like keeping the same pseudonym everywhere. Okay, so let's talk about distributed systems. What do we call distributed systems? There are lots of definitions. One is, okay, a distributed system is something that fails because some random machine you've never heard of breaks. Okay, that's one definition. I'm going to focus on a specific class of distributed systems, where you've got a set of autonomous interconnected services, and what I call a service is a set of servers running some kind of a similar application with its own database. You already cached it or memcached it or whatever, but basically you've got one service, which is, for instance, your accounts database and service and those applications, or accounting, or it talks over the network. I'm not here talking with the browser and the application servers, load balancers, database. I'll say this is one service in my vision of distributed systems, which I'll be talking about today. So, small idea of what I'll be talking. Why should you switch to a distributed system with lots of various pieces between talking with the network? Okay, when do you deploy it? How do you build it? Okay, a small focus about talking over the network and remote procedure call systems. And then how do you keep it running, maintain it, upgrade it, test it, and so on. So, at the beginning, you're starting your project and you've got a wonderful, pretty clean design. Perhaps some people will recognize it. So you've got your applications, your modules, each box is a small model, it's pretty, it's great. And then, 2 years later, well, you added new features, and you did some refactoring, and you had auditing, logging, debugging. You had new needs for marketing and sales, and you had new features, and so, yeah, okay. That's a small extract of our graph models. Each box is a model, not a field. So at this point you think, oh, maybe it's time to split things to keep it manageable. So yeah, that's it. So that's our architecture a couple of months ago. So each box is 2 or 3 servers for redundancy. It's each small square. So this is internal operations, web services, cron and various tasks. So you've got all your small services, and then each big box is a service. And everyone is talking to each other with the network, and yeah, it's simpler. Each component has a simpler task and provides a smaller set of features. But now you've added another level of complexity. How do you manage upgrades? How do you? So, when would you create a new system, a new distributed system? So, basically, someone tells you, hey, I've got this new idea for a new product. Okay, it's not exactly the same thing as what we've been doing. So it's like you've been doing carpooling service for individuals. And you say, hey, I want a carpooling service for businesses. Okay, it looks the same, but it's actually totally different. So it's strongly disconnected from the core. It's not a small incremental improvement like I want to implement a new offer or something. And you need to launch it fast, so you don't want to have to manage to update and upgrade your existing system with those new features, because you've got already 200 models and 500 views, and you can't even print your area mapping on an A0 sheet. Yeah, it's too big. And even if you manage to get weekly releases, yeah, it's big. So you want to build it fast in a single separated app. Okay, that's a good idea to begin splitting your complicated system into smaller, more manageable items. The conclusion is, okay, you're installing a new version of your main product, so it's exactly the same, but it's for it's another brand, or you're installing another data center, or it's a separate database because, hey, now we're handling English customers, and so we are not allowed to put them in the same database as the French customers because legal. And yeah, okay, the two services, it's two databases but it's a single operation system, like a single Salesforce, a single, it's users, your internal users are the same, and they have to manage cases to handle on both, or 1, 2, 3, 5, 10 different installations. It's kind of getting you like to have all your notifications aggregated in some command to use RSS aggregators to get all your news in a single app. Okay, you want perhaps your users to have a single place to look at in the morning. Okay, what do I have to do today? Oh, it's here. Okay, perhaps I'm going to connect to 5 different systems running in 5 different countries, but it's one single entry point. So that's a good idea at this point to add this small system that will just aggregate your to-do list from all your systems. Or basically because you need to improve technically what you've been doing, you need to debundle your system and to be able to make faster upgrades. You have some geographic expansion, and so, well, you've got some latency critical systems and you want to be able to run something in the US, something in Europe, something in Asia. And yeah, it's kind of difficult if you've got everything coming into the same single PostgreSQL database. Or you want scaling and throttling, and so you're going to have lots of similar nodes and less things on each one, or splitting your customer data in different sets of servers. When you're in one of those situations, it could be a great idea to isolate a part of your application and make it a separate service. So, let's build it. So, first thing, you've decided, okay, great, and I know I'm going to split something. I don't know what exactly, but I know I need to split something. Someone at DjangoCon said I had to, so I did. So, well, you extract your generic code. So, I guess you all have MISC, utils, tools, whatever component in your project, right? I mean, who doesn't? Everything is business specific, like you've got some authentication, custom authentication backends, but it's not actually related to your business, core business features. And perhaps some basic business components, like the company is always running around selling things. Okay, but well, perhaps everything about a sale is so common and so standard that you use it in all your applications, all your services. So perhaps this is something you can extract in a common generic library. What's great is, so you just put it in a separate module, a separate Django app or Python app, and then you start learning to manage dependencies between two modules that you develop. Because having a dependency on Django, okay, Django upgrades once, twice, 3 times a year, so you have one big upgrade. Now if you're developing 2 libraries with the same team at the same time, every week you've got upgrades on both sides, and you've got to manage those strictly coupled upgrades. Oh yeah, you don't have to upgrade your deployment process, but at least you're still just deploying a single program on a single set of servers, the same program everywhere, but now it's got more moving parts within it. So you're getting, you get a sense of how more complex it will be if you start small. Then, okay, something very important, you're going to split your system in smaller chunks. Great, but you don't want the user to see it. When you're going on Gmail and you open Calendar, okay, it's not exactly the same app, but it's still a Google service. And basically, you should provide the same kind of experience to your users. So, extract all your common UI templates. I hope you're not just copy-pasting your HTML everywhere, right? Perhaps at the top navigation bar, or perhaps a small set of squares or whatever, but something to ease navigation for your users. Ensure your assets are properly built, because you have some common CSS, some common JavaScript, and you want to integrate it with other things. So like here, maybe playing with Bower, Grunt, which are JavaScript tools, yes. But it's JavaScript you're talking about, so it's kind of relevant. Could be a great idea. I think we'll have a small thing about this in an upcoming talk. And user experience is not only about design, it's also about the user flow. when you're connecting, when your users, internal users or customers connect to your service, you don't want them to think about, oh, okay, now I need that, so I go to the accounting website and then I log in there, and no, it has to be perfectly transparent. So, you need to have a single sign-on. It's not centralized authentication. Centralized authentication means we've got the same login and password on every site, but you have to type it everywhere. Single sign-on means you open one page, it says, hey, please log in. You log in once per day, or per week, or once per session. And it's magically connecting to everyone. So for your web customers, you want some kind of OpenID-like technology, but an OpenID where you don't have the user to provide his OpenID. You just redirect him to the OpenID server because you know he has to be authenticated there. And if you're using for your internal corporate users, well, try to deploy Kerberos. Yeah, it's kind of an enterprise stuff. You know, it's connected to Active Directory, and it's great. Let's talk about a little bit about Kerberos. I love it. So it provides you with a very efficient and secure authentication. You never have access to passwords. It has very, very strong encryption. You can enforce various kinds of security and complexity characteristics in your passwords. So you can have it with Microsoft Active Directory, or you've got an open source MIT implementation, which works pretty well. And it works for customer, for user OS with Mac, Linux, Windows. Okay, basically, I've just got two slides, and we go back to distributed systems and networks and Django again. So, how does it work? First, we authenticate against a secure authentication server. It's called the KDC in Kerberos. You receive a ticket. So this ticket is basically the server saying, yes, I validate, this is him. It's Raphael. Trust me. You connect to a server. The server sends you its ticket. You send them your ticket. So both sides know that you know you're talking to a valid server. The server knows he's talking to whom he's talking. So everyone is validated if it's fine, it's complex crypto, but you don't have to care about it. And so everyone knows who's talking to whom. It works. Obviously, you'll have no networks for mail, SSH, FTP. It also works for websites. It works for Firefox, for Chrome, for Internet Explorer, obviously. It works with Apache and Linux. Well, I had to slightly patch the module, but it works. Production, progress. You just have to say in your browser that, yes, I trust this website to be an authentication trusted site, and so I can send him my ticket, because you don't want to send your ticket to any random website and send it. And if you have not performed secure, proper Kerberos authentication in your shell or password prompt or whatever, you'll fall back to this ugly HTTP box. Please type in your login password, and the server will handle authentication for you, and Django just receives the remote user HTTP header. So you don't have to care about authentication from storing passwords, deleting passwords, revocating accounts. You perform that in an account management system, a Kerberos, or a DAP. But you don't handle it anymore. You just have a system above that say, hey, this is Raphael, trust me. It also works for AJAX requests, although it's slightly more complex, especially in cross-domain requests. But we managed to get it working. We just have to write some blog post about it. So, back to our system. Okay, we know we've got a proper, beautiful authentication, so the user will only log once. Now, you're going to split your system. Yeah, great. But you're going to move some of your code to another component. So, you've got a few key design rules to keep in mind. First, always be sure that you've got a single source of truth for every data. Okay, who's responsible for creating an account, following which accounts are active? If you've got them replicated everywhere for performance reasons, you need to know where to look for the truth. That's very, very important. If you don't know which side, yeah, okay, everyone has its own data because it's all distributed and they did not manage to sync, and where should I look? Who knows? That's right. Especially when you're talking about, for instance, financial data. You don't want to have someone who says my balance is 2,000 euros and another says, no, you've got only 500. And if one is off, you want to know which one. Okay, so you're going to split your system. Do not split per model or bar. Right? Okay, I put all cars there. No. You want to split something which is a business domain, a coherent business domain, like but all financial systems, like billing, accounting, pricing, Embiez. Okay, that's globally coherent because very few requests coming in, very few requests or data getting out. Yeah, you could make that a separate system. You've got your bootstrapping system where every news, I don't know, your factory is building new gizmos and the single entry point for gizmos. That's perfect. Don't think, okay, I know I pay subscription, because perhaps subscription is at the meeting point between all parts of your system. So pick a consistent business domain, and you'll get a bonus feature with that. When some business team needs a new feature for their system, you will just test it, and since you split your system, you know that you're not going, well, you're less likely to break other parts of your application because you just split things per business domain. So I'm great, just regard this more check. And don't forget about redundancy and availability. So where do you begin? Okay. So I said loosely coupled isolated modules. Perhaps you've got something to manage ACLs and access control permissions. At some point you know that you're going to have audits or something and you want to be able to have a single pretty dashboard which tells which user has what permissions on what systems. So that could be an idea. You could take that and say this will be the source of permissions for everyone, and it will push new permissions and new permission to map into everyone. Or perhaps you want a single registration and account management system. Perhaps it's finance. Well, basically something that is its own isolated system. One bad idea, we did it and we will try not to do it again. Don't rewrite the module you're splitting before splitting, right? Oh, I'm going to put my financial system separately. Let's rewrite it, by the way, because it's lots of bugs and it's complex. No. It's already complex enough to split it and suddenly add a network barrier between two functions. Don't change the business logic at all. So first, you know what data is getting in, what data is getting out. So within your code, you enforce your physical barrier, like you're not allowed to call models or filters or anything. You just have this single entry point and list of functions you're allowed to code. And once you've managed to isolate your module so that no one outside it is calling its code, no one is touching your models, then you're ready to move it on another system. But rewriting is So then, you've got your new system, you're ready, you've got all of your APIs, internal APIs. Great, now, you start with a remote module which runs basically the same code, but instead of taking direct in-memory function calls, it takes network calls. Then, you had a small layer in your local code that says, hey, every time you send me a request, I perform it locally for purpose compatibility, and I send it off to the network. If you've got bottlenecks, you'll see it at that time in production, and you can just, oops. Okay, let's fix it first, and then we'll make the big jump. Okay, once you've got something that works with writing locally and remotely, you just say, okay, now I just simply always use the new remote module once all the data is inside. And then you remove your adaptation layer, you remove the old code from the existing system. Congratulations, you've switched. Okay, I've just been talking about the remote procedure calls. Yeah, it's kind of outdated. Everyone is talking about REST APIs, right? So, yeah, everyone is doing REST because it's kind of standard, but not a standard, but it's a set of best practices. And yeah, but REST is about resources. What you're doing when you're splitting is you've got a few entry points, a few functions you're usually creating. So you know you've got create customer, and you pass in a set of keywords, and it returns you a reference to customer. Okay. So you could put on your REST, and then you've got updates on status or disable, and then you're going to add lots of sub-resources. So begin with something simple. Begin basically with exposing the methods you need, and so just do RPC first, and if you've really managed to split your systems in isolated components, and you no longer know who talks to your system, perhaps then REST API may be used. Also, you'll have performance issues often with REST API, because I want all customers on their address. Okay, but it's two different resources, so I've got to do first query to get customers, and then to get resources by doing some complete filtering. Okay, now you know you want customers and addresses. Well, just call a method which gives you all. And it's much easier to both from internal in-memory function calls. Okay, a few important points about the technology you're going to choose. You have to have a look at authentication and security, even though you're calling in between services in your data center. At some point, the team are going to split, not talk enough to each other, and so you no longer know which methods you're supposed to call when, and what is dangerous and what is not. And if at some point someone gets root access on your front ends, if it still has to authenticate for its backend, it's better. You have to think about changing the schema, so all your APIs, you need to add new methods, new attributes, new options. Okay, that's a very complex thing to do, so think about it before choosing your technology. And obviously, it's going to break, or you're going to have to audit it and find out, okay, I thought I clicked on the button and something happened, but I didn't. Where did it break? So you need to have perfect, very exhaustive, complete debugging and logging tools. For instance, if you can get all your logs or your Django, Python logging calls coming into a single file on a single server for your whole application in the data center, that's going to be much easier to debug. And Syslog is pretty great at that. So, security, basically you don't want to trust the front-end system. Okay, it's saying you add 500 euros to this customer account. Okay, yeah, well, perhaps one made a bug, perhaps I don't want to at least know whom is asking this. Whom should I trust? So push me a proof of identity. Okay, at first you're not going to have very cryptographically secure delegation of identity, but at least have some kind of proof that the request is coming from the actual real server that is supposed to send this request, and not someone who is playing on your production network and sending requests wherever it can. Okay, perhaps the front end has to perform some authorization checks. Yeah, with okay. Just as you perform permission checks in your views, even though you don't show the form to someone who has no permission to post, you still check when you get a post that he was authorized to perform that post. Okay, another very important topic, and we talked us about in the past couple of years, changing the schema. You'll always go through lots of iterations of your API. You'll never get the right API perfectly from the first try. So, if you've got a very strict schema, like a request must match exactly this access date file, which says what is allowed, what is not. Well, first you'll have to deploy a new client that can receive all data, all formats, and new formats. Then you may be allowed to upload the new server that is compatible with the old and the new format. Then you can, as the client, use the new features. Great, yay. And once that's done, you can, at last, remove the old contract from both sides. It's kind of complicated. If you've got a more flexible schema, like in a JSON, you're just reading fields, and if there is a field you're not interested in, you don't read it. You just don't read because there is an unknown field. And that's much easier. Okay, first you've got a new server with a new contract. And sometimes, in its responses, there are fields that the client doesn't know, so it doesn't care, so it doesn't care. And then, you can deploy your new client, which will send new requests, with new fields, new options, new features. And it just works, so you just do 2 deploy instead of 4, and 5. So, yeah, choose your protocol serialization layers well. You need to have a support for optional fields and putting a default value there. You must be ignoring unknown fields. And perhaps having some path-like notion, so it does not need to be an HTTP path, but at least something that looks like a path, so you can increase your version number. Say, okay, I had /API/v2/cars, and now I'm going to /API/v3/cars. So say I've changed everything. So okay, it's just like in semantic versioning. Okay, you've changed your version, you've rebuilt your API. Okay, you create a version. If you don't have anything like that, so for instance, you are using JSON RPC or XML RPC, and you're just calling methods exposed at the root of the system, it's going to be slightly hard. So, okay, what makes an RPC stack? You've got 3 big layers. You've got the transport. You might be doing HTTP, plain TCP, 0MQ, AMQP, whatever. You've got a serialization layer with JSON, MGPAC, Thrift, and you've got the actual RPC layer, the thing that has method calling semantics, like JSON RPC, SOAP. Who enjoys SOAP from? Yeah? It's great. It's not that bad. Okay, so your transport. You need you've got three very important things there. You need to have some kind of load balancing. At least because you want to have always 2 servers providing your application, not just a single, if it fails, if you want to do an upgrade. So you need to support load balancing. It's much easier to do remote procedure calls if you're message-oriented. What do I mean with message-oriented? It means that you can send a message, which is self-contained at the beginning and at the end, and it's a message going in and a response coming out, and not just sending raw bytes, and then you've got to find out where's the boundary between where a message begins, whether the message is finished, or just you've got some lost packets, and so it's been 2 seconds without data, but is it here already? Well, okay, we're in 2014, so obviously you're using async IO everywhere, right? And yeah, having some request response on asynchronous support. A request response, I send a request, I get a response immediately. Asynchronous, I send a request with a request number, and at some point I get a request a message coming in which is a response for the actual original code. So I've considered a few options. You've got HTTP. Okay, it's great for load balancing. You already have plenty of tools to load balance HTTP because hey, everyone is using HTTP to the point where they think here that HTTP is a single protocol and it doesn't exist. It's good for debugging because same thing, you've got lots of tools. It's plain text, so it's pretty efficient. Yeah, okay, it's plain text, so binary data, not so good. You want some pictures, okay, you have to paste 64 and put them. Okay, you've got AMQP. It's good for the balancing, and RabbitMQ is pretty impressive. It's doing full asynchronous and binary messages, great. Yeah, but you don't have time-critical request response because it's basically a queue. So you send a task, do this, and at some point you'll have a response. And will it be in half a second or 2 weeks? Well, you have no way of knowing. Well, you don't have more ways of knowing with HTTP, but if you've got a problem with your HTTP connection, you'll get a network timeout immediately, which you won't have if all workers are dead for your AMQP queue. You might go for 0MQ. It's great for asynchronous things, binary messages, performance, but you have to roll out your own load balancing. I didn't find examples of already implemented load balancers for 0MQ. Why does it work for HTTP and not 0MQ? HTTP, the idea is every time you send a message, you open a new TCP connection socket to connect to your server. So the load balancer will send your connection to randomly or not to loaded server. 0MQ, you open a socket once when you start the program or send the first message, and then you reuse that socket all the time. So when you start your client, the load balancer will load balance you to some random server. And then all your messages will go to the same server. If you do it just naively with a simple socket. So you've got to put the middle one, basically load balancer. You connect to the load balancer, it takes the message and sends it to one of its connected clients. So it's slightly more complex. So perhaps don't start with it first. Plain TCP, yay! I want to write my own protocol. I always wanted to be part of IETF, and I never managed to get there, so yay! Yeah, it's great. But TCP, well, it's a streaming protocol, so you'll have to find a way to define boundaries between your messages. So, yeah. Oh, yeah, okay, then I use UDP. UDP is message-oriented, great, yeah. And I can design my own protocol, wonderful. Yeah, well, you don't have very proper request-response cycles with UDP. Let's not talk about monitoring or losing packets. You don't have basically any guarantee about whatever will go. Okay, so let's go to the next layer, your serialization. Basically, what you want to do is to take your request object, the objects you're passing to your method, send them over the network in some kind of compact form. So you want to have support for complex nested objects, i.e. some kind of efficient packing. I've got a thing for schema validation, so yeah, schema validation, and perhaps not too strict schemas. And if you could have enums, datetime, or any custom types you'd like to have, yes, that would be great. Okay, so let's see what it does. MSG pack, so basically it has a standard format to pack any kind of message of object structure into a set of bytes, send it and decode it. So it's very efficient for packing, but it has absolutely no schema and no custom types beyond the Python built-ins. You can have a look at Google protocol buffers. They are very efficient at packing. They have a very great schema system where you declare fields and they are optional. So if you get a field that you don't know, you don't fail, and you send back the message afterwards with just having updated a couple of fields. So unknown fields are still there and go back on the wire, but very interesting. But you don't have custom types. And it's the main branch is not Python 3 compatible, but I think there are a couple of forks available. JSON, not very efficient for packing, but you could go for binary version. You've got no schema, you don't have any custom types, so you've got to implement your datetime fields as either an int64 or ISO 8601 string. XML, okay, very strictest schema ever. Very advanced types, you've got date times, you've got durations, you've got times, you've got any kind of field you can imagine you've got them. It's not exactly bandwidth efficient, I think. Perhaps someone would think that you could use pickle. No, you don't want to have, well, basically pickle needs the same code to be available on the sites, and it's tied to Python. And perhaps at some point you think, hey, let's implement this new service in Go, or in Scala, or whatever. Oh, damn, we use pickle. Okay, we do it in Python, or we'll do Python to JSON conversion here. Don't go for language-specific serialization. And then with that, you've got your application layer, so the thing that provides method calling semantics. So you need authentication, schemas, and ambiguous serialization. What do I mean with unambiguous serialization? I mean that a given object cannot be written in more than one way on the wire. And the library you'll use for this application layer, you'd like to have a library with good logging, good debug features, very simple client calls, like I just instantiate my client and call a method and it works, and I don't have to worry about anything more. And it's easy to declare my service on the server side. And yay, async.io compatible. So you've got JSON RPC, pretty well-defined serialization, no authentication, so you have to do it at the HTTP level. And it's usually just any defined function in your module can be called, or perhaps any exposed application can be called. So you have to write some code which says what you can call, what are the arguments, what's the meaning. XML RPC is the same thing, but it's XML. SOAP XML, okay, you've got authentication, explicit strict schema, and it's XML. So you've got 20 different ways of writing the same thing. And so you've got lots and lots of libraries for SOAP in lots and lots of languages, and all slightly incompatible. Wonderful. You've got zero RPC. Didn't manage to find the spec, so perhaps there is one, but I didn't find it. You don't have CORF, and you don't have explicit schemas. And JSON/REST/ some kind of custom thing. Yeah, it's not a real, well, REST is not an RPC standard, but it's kind of documented for you to use it. So, what I go for? In the beginning, okay, you've got already enough programs on the side, so go for HTTP, JSON, and some kind of REST-like system. Just to put a post on some predefined URL, and you'll be able to go fast and to build your app and have something that works with technologies you know, and you can debug and you can log, and you've got authentication. It's great. And then at some point in time, you want to have more efficient, faster systems. So yeah, perhaps at that point, think about 0MQ or AMQP, depending on what kind of whether you're doing synchronous or asynchronous calls, protobuf, and some protocol, but I find that there is lacking something. So perhaps Thrift is a way to go here. I don't know. I have to look at that. We are currently in the state of moving from the kind of upper level to the lower level. So hopefully we will be able to open source our RPC layer. Okay, now you want to maintain it and keep it running. So you've got reliability and redundancy. You've got to manage deployments, upgrades, splitting additional modules. So reliability, the service should either be mission critical, like every incoming request has to send a request to that service, so it must be always up. If it's your authentication service, it has to be always up. Otherwise, you don't authenticate incoming requests and you just end in flames everywhere, so it has to be very, very highly available, because it's the only place version that I saw. Or it's an authoritative data store, but all your client services are caching it for performance reasons. Okay, then you need to have a pretty secure and basically some very, very well-tested synchronization system, which handles also past failures and so on. So yeah, caching validation, one of the most difficult things in computer science, and yeah, provide automatic synchronization. For your upgrades, you've got new challenges, wonderful new ways to break things. Great, so you've got inter-system dependencies. So A depends on version X of B. And how do I manage to create A or B with networking combination on requests going on? I check my contract, and I've got my shared UI library, my shared authentication library, which is the same model I use everywhere. Okay. So, interested in that, well, you've got a critical service that just cannot go down. You have to play with your load balancers to remove one server from the pool, update it, bring it back, next server, and so on. If it's a backend nobody uses really every day, or you can say, okay, don't register a new factory for 1 hour to add you that when you want. And if it's a customer-facing, user-facing service that relies on lots of backends, you still want to go for a progressive upgrade, dating one server to another, because perhaps you've changed the way you're talking to the backends and you won't discover it until you're running in production with real requests coming in and real request volumes. So ensure you're still compatible with your upstream services and you're not killing them with 10,000 requests a second where you were at 10 requests a second before. With your contracts, so if it's a small change, just manage to change the parts of the contract that talk about this feature, and okay, it's done. And if it's a big change, like okay, I've rewritten everything, or the semantics have changed, okay, I've just bumped the version number, just like for a library, and just make sure that all clients get upgraded. So I'm sure that you've got some way of knowing when you get an incoming request where it's coming from, which server has not been updated, who's still running the 3 years old contract. So that's one of the good reasons to have authentication, just to be able to track which client the system is coming. So you've got shared libraries. Okay, you've got basically 3 kinds of upgrades. You've got a security upgrade. You found a bug or basically a vulnerability in some of your code. Okay, you've got to deploy it as fast as possible. So you need to upgrade all your systems using that library very, very fast. So yeah, it's not gonna be fun, but you have to. You've got a new major feature, like, okay, now our UI supports Bootstraps 3. Oh, great. But it's kind of dangerous, so we'll wait for the next big upgrade. Or if you've got a few bug fixes or things like that, okay, you use them. So next time you upgrade. What's important is basically to keep your set of dependencies to a few, like 2, 3, 4 different versions, not 20 different versions. Like this service there, it's running with code 2 years old, no one has touched it. Okay, it's dead. You're not going to be able to upgrade it. So don't use, avoid using obsolete code, because sometimes you will have to build a new feature and this uses all the APIs, nobody understands them anyway. How do I do it? And the less versions you put in production, the less bugs you need to remember. So run many tests. So you've got your current production branch running with the exact current production dependencies. And then you've also got your current production branch with the latest version of dependencies. This way you know when a new dependency is breaking backwards compatibility, and you can fix it before you get to pull out a hotfix. You've got your current master with the latest dependency for production, so you could still, you've not broken or you're still using the old APIs. And so your current master with the latest dependency, because hey, that's the next thing you're going to deploy, so it's better to know it works. Okay, testing. Progress is almost over. You've got several levels of tests to make, so server-side contracts. You want to make sure your server code runs well, because you might test your clients in isolation or a full system test. So server contracts, basically, you could connect a fake client with an in-memory transport, so exactly just like the test client in Django, which fakes the HTTP request. Sets the full stack, errors, authentication logins, and it's fast, so it's great. You can send already desirable directory to the server code. While you go slightly faster, but you skip some layers, it's perhaps not the best way to test it. Or you connect an actual client with a real transport, just like a license test case. So it's closer to real setups, and you might add some tricks in your test setup to perform like network failures, the client makes early or often minutes. So at some point you need to run multi-threaded tests, at the time where network is involved, at least until we've got IO Django, but I don't think async IO in Django is likely to come at time in this decade. So when you're running live in this case, you've got one thread which is running the tests, and one thread which is listening on the network to handle incoming requests. Okay. You might have also thread in some parts of your production code, like you've got something that does a batch of operations and you spawn 12 threads to go faster. And when you're testing it, you have to use a transaction test case. So for those who are not very aware, transaction test case does not run your tests in a transaction. Test case does each call in a simple transaction. Transaction test case flushes the database after each test. Okay, it was getting a pain, so I've written a small tool called DjangoCon. I success naming things. Basically, it sends all database information is a single shared thread. So you can come back and use a normal test case with multiple threads and still roll back the transaction after your test runs. So you should gain a few seconds on each live server test case and zero tests. It's not been well tested. I only used it with SQLite and PostgreSQL, but I'd love to get some feedback on that. And you've got also your multi-system test, like you've got 5 different components talking about the net across the network, so you're sure that each one is globally correct in its own. But is the whole working properly? How do I handle the full life of a customer in my application? Yeah, perhaps you've got to have a more complete, accurate system test. It's pretty complex to set up. At least I didn't find proper tooling for such tests where you've got to run code on several systems and talk to everyone and launch everyone and write complex scenarios. And yes, it's a wonderful giant Selenium test. So it's very, very slow. You've got 5 different Django applications running with each its own Postgres database and all your tests. And, yeah. So I tried to, I'm working, it's not finished yet, but a new small library based on a Python library called Pyro, Pyro, for Python remote objects, which is a way to run code in a remote interpreter, even across virtual environments, even across network boundaries on other servers. So it's good. I'd love it to be great. Should be released within 1 month, I hope, with hooks for synchronizing test cases, so that you can say, okay, when you enter this test, you begin a transaction on all 5 remote servers, then use queries for HTTP, then you check that everything is properly set up in all databases, and at the end of the test, you roll back every transaction. So it should be compatible with DjangoCon. So the idea would be to get some kind of test like that. So you say, okay, I'm connecting to a few servers. I'm connecting, so here I'm importing a proxy to a remote module. So here I'm running in some place which has no Django installed, for instance. I code a factory on a remote object. Then I import also models, but it's actually this code is running in the remote server. I create an object, I get it from my user pass, and it says, yes, they are equal. Even though they are proxies for 2 objects living on a remote server on the other side of the office. And you can call methods, remote methods. So all this is working, I just need to write documentation and test, but it works. I can call remote features and things like that, so I'm hopefully being able to deploy it and publish it soon. So that's over, I think. So do you have